Hey guys, so section 5 is crazy. In chapter 4, we're going to be starting to factor. Okay, so breaking down polynomials by using the greatest common factor, right? It's called grouping. So we're just going to learn how to do grouping, and then we'll learn how to work with quadratics in the next section. Okay, so factoring is just rewriting a polynomial in a simpler form. Okay, the easiest way, first way to do that is by grouping, and grouping is just basically undistributing the greatest common factor. Okay, so if you have something that's already distributed in, then it would be common in all of the monomials that form your polynomial. So if you could take all those out or undistribute those, right, that's going to make it simpler for you, which is ultimately going to help us solve polynomial equations, which we'll get to at the end of the chapter. All right, so there's also some special cases here. So you've got perfect squares, perfect cubes, right, which basically you'll need to eventually memorize what these formulas are, right, in order to use them for factoring. So these are special cases, right? So if you see something that looks like this, a squared plus 2ab plus b squared, it can factor down into a plus b quantity squared. Same with a squared minus 2ab, right? Notice the difference here is these two, right? Translate to those two. Right? Those are going to be the same, and you might remember this from obviously multiplying. And the last one here is called a difference of two squares. So if you have perfect squares that are subtracted between each other, right, you could break them up to a plus b times a minus b. The perfect cubes, right, there's actually a mistake in here. You're going to have to change this. The second one should be a minus b here. Okay, so they look very similar. Right, so if you have a perfect cube plus a perfect cube, so a cubed plus b cubed, right, it breaks down into a plus b times this whole quantity. Okay, same thing for a cubed minus b cubed, a minus b times this quantity. Now, one connection you might make that is not going to be good for you, right? You might look at this and think it's actually one of these perfect squares, right? Right? It's not. The difference is the 2. Right? The 2 doesn't appear in the perfect cube formula. Okay, so it's not quite the same. Don't confuse yourself with that. It's kind of confusing, I know, but let's see some examples. So we're going to start by factoring. Right? These first ones. This first one is just grouping, so that's good. Right? So what we're trying to do is we're trying to find the greatest common factor. Okay, so if you need help with greatest common factor between these two, right, you can obviously go back to the previous section and watch that video again. But hopefully you're catching on, you're able to catch it pretty quickly. Okay, so you should see that the greatest common factor between 24 and 40 is 8. Okay, and then for the x's, you just pull out one x and you can pull out one y. Now what happens here, when you undistribute it, basically we're taking that 8xy out of both of them and putting it in front. So you got to figure out what's left. So when you divide an 8 out of 24, you're left with 3. When you take 1x out of the x squared, you're just left with 1x, and when you take 1y away from 1y, it's just nothing. Okay, so you're left with 3x, and when you take the 8 out of 40, you're left with 5. You took the x and the y out, so that is it. So that's how the first one factors. Now, a couple of just situations where you could see those special cases and how they work. Right? You're just going to need a lot of practice with it because you need to be able to recognize them. Right, so we have x squared plus 14x plus 49. Hopefully you recognize something like this from when we multiplied back in section 3. But if not, let me show you real quick. So here x is a and 7 is b. Right? So if you go back to your notes and look at what that perfect square formula says, it says that a squared plus 2ab, right, which would be 14x, right, equals b squared, which would be 7 times 7, which is 49. Okay, so the way this factors is it factors down to become just a plus b quantity squared, which is x plus 7 quantity squared. Okay, so if you see a perfect square here, right, then take the square root of that and double it, and if it appears here also, that's when you know you're going to have that perfect square. Now number 3 is an example of the difference of two squares. Okay, so if you see a minus sign, two things that are subtracted from each other, you always check to see first, is the first one a perfect square? Is the second one a perfect square? If the answer to both of those is yes, it's a difference of two squares. So what's a and what's b? Well, a here is going to be 9, and b is going to be 2a. Okay, those are the perfect squares, right? The square root of each of those. So we have a plus b, 9 plus 2a times a minus b, 9 minus 2a. And number 4, okay, we see our perfect cubes, right? Once again, if they're not perfect squares, check to see if they're perfect cubes. They are both perfect cubes, so this example has a being a still, and b being 2. Okay, so this is a difference of 2 cubes. So we've got a minus b, so a minus 2, times a squared, plus ab, 2a, plus b squared, which is 4. And that is factored. That definitely looks more complicated than the a cubed minus 8, but I promise when we get to solving equations, you're going to need to be able to do that in order to actually solve the equation. Number 5. Okay, these 5, 6, and 7 are very difficult problems. Okay, so these are higher level problems, but I want to show you some examples of how to do them, all right, before you get into class and start working and see these and then freak out. So number 5 here is a double grouping problem, actually. Okay, so there's 4 terms here. There's nothing common to all of them, right? So it's kind of hard to work with, right? But there's one way that you can factor this, right? And it's actually grouping twice. So grouping the first 2 together and then the second 2 together, and then we'll see that there's going to be common between your 2 terms after that, even. Okay, so we're going to look at these separately. So what's common between the first 2? It's an x. Right? We take x out. You're left with y plus 5. And the second one, 3 is common, so you are left again with y plus 5. So you see here, it just kind of works out really well. Once you play around with it, you'd see certain things that would help you, lead you in this direction. But now you see that you've got 2 terms here, right? The first term and the second term is x, the x term and the y term. Or, sorry, the x term and then the 3 term. Right? Both of them have y plus 5 common, so you can distribute that again, and when you take the y plus 5 out, you're left with the first term, x, and in the second term, you're left with 3. So that's what it factors to. Y plus 5 times x plus 3. Number 6. Number 6 is like a double step problem. Okay, so first, you just do grouping. You always look for grouping first, right? So you see anything common here? Yeah, you do. You see a 2u that you could take out. So you're left with u cubed plus 27, right? Now you got to keep looking. Don't just stop there, right? Keep looking to see if it's completely factored. All right, the first thing, obviously the 2u you can't do anything with, but the u cubed plus 27 is a perfect cube. All right, so since that's a sum of 2 cubes, we've got our 2u, and then we can factor our perfect cube there, 2u plus 3 times u squared minus 3u plus 9. Perfect. And the last one. Alright, the last one is, again, just kind of really hard to see. It would take a lot of time and practice to get to this point, but these are the types of questions that you're going to be facing when you do the work with this stuff. So, you look at this and you're like, well, there's nothing common, so that sucks. Can't do a GCF, can't do grouping. Alright, so it's probably one of those perfect special cases, okay? It's actually a perfect square, right? Because you see a perfect square here and a perfect square here. It's usually should ring a bell in your head that like, oh, it might be a perfect square. Right, so what you do here is figure out what a would be and what b would be. So a would be the square root of the first term, which is 2m to the 4th, and b would be the square root of the second term, which is 3p to the 6th. Okay? Now, you look at this and you see, well, would this be 2 times a times b? Well, this would be 6, right? M to the 4th, p cubed, right? And then multiplied by 2 would give you 12. So it does actually work as a difference of 2 squares. Okay, so our a minus b quantity squared is just 2m to the 4th minus 3p cubed quantity squared. Alright, so the way to check these, right, if you are struggling with them, is whenever you factor, right, then check it, right, because we already did this multiplication type stuff, right, back in section 3, so check it, and you should get the exact same thing. Same way with number 6, and obviously every other problem that goes along with that. That's it for that section.